Hola, soy Alejandro Sahuquillo y estoy aquí una vez más con el grande, el inigualable, el increíble Joe Justice. Joe, nearly 1 month ago, it was the grand opening of GIGA Austin, the benchmark of all the factories. And it's been a pleasure. We're really honored the Tesla community because we have so many insightful, smart people. And we've heard the opinions of engineers, the experts manufacturing such as Sandy Munro, also of battery experts such as the limiting factor, of great YouTubers, Rob Marver, Dave Lee, Hyperchange. But every day I'm looking on the internet, what is the opinion of the man who knows about innovation, Joe Justice? So I'm really pumped. And as nobody, or I guess I didn't find the information of your opinions, that is the reason of this call. So please give us light of what was your opinion of the Cyber Rodeo and the GIGA Austin.
Alejandro, it is my honor to be collaborating with you again. Thank you so much. What I think many people have not realized yet is in most manufacturing facilities around the world today, the factory floor plan, if you look down like a map at the factory, it looks like it's set up for a line, like a snaking line. And even Sandy Munro, who is amazing, and I had the chance to meet in person in Texas, said, I see how much extra space is next to each of these areas. They have so much room to grow. But Sandy at least didn't say what that means for innovation other than room to grow. So I'd like to try to be clear. I think this is not yet understood by most people. Most factories are laid out in a line and they leave room for a line, single one-piece continuous flow. The problem for innovation with that is if you introduce a change at one step in the line, every subsequent step has to be adjusted and tested to accommodate the change. And in fact, every step before has to be adjusted and tested to create single one-piece continuous flow into the change. This is why most factories change less than once a year. And when they do, it's a shutdown, usually over a holiday break, where they shut the factory down and a separate team comes in to make the change to the line and test flow going in and out. That's way too slow for how Tesla operates. And this is what I got to see working in Fremont. In Fremont, California, that building used to be owned by General Motors. And the concrete, it's a huge concrete building, set of buildings, is shaped to accommodate a line, a snaking single line. Then Toyota bought the facility and still operated in single one-piece continuous flow. Tesla bought the building and they don't flow that way. It's too slow. Instead, they have lean cells. If you look down on the Tesla factory floor plan, it's like you're looking at hexagons, a tile map, like you're playing a strategy game like Risk or Carcassonne. Well, it's actually better than that. It's three-dimensional. I don't know what the word is for a three-dimensional hexagon, but it's that. So to simplify it, you could think of it like cubic meters, but it's actually more like hexagons because each cell sends on the angle as well, not just up, down, left, right, forward, and back, but also all the angles. And you might have an area here making seats, and they'll be sending here to Model 3, and here to Model Y, and here to another area of Model 3, and here to S, and here to X. Well, there's another area, in fact, more than two, also making seats, and they're sending off in different directions to different parts of S, X, 3, and Y, and prototypes as well. This is unusual in manufacturing. In fact, this is bizarre. There is no line. They flow three-dimensionally. What Tesla's had a chance to do in GIGA Texas is design a facility for the way Tesla manufactures. As a result, the structure of the building is unlike what we usually see in manufacturing. Yes, Sandy Munro did say there is extra space. There's a lot of extra space, a lot of room to grow. That is important, but it's what is the shape of that space. The lines are not lines. You have these three-dimensional spaces across all the vertical height of GIGA Texas. And there's enough gap between them to introduce intermediary steps, more lean cells, more agile cells between them to stack. If you were playing a three-dimensional board game, you don't have one piece directly feeding the next right now in GIGA Texas. You have gap for one or even more in between. And those gaps are big enough for a Tesla Semi. This is important. Already we've seen superchargers with stacks of battery packs. They're basically Model S battery packs for remote deployment of superchargers. When I was racing at Laguna Seca with Unplugged Performance and Tesla Corsa, Laguna Seca racetrack in California in the United States at that time didn't have its own Tesla supercharger nearby. It was not very close. So Tesla brought in on the back of a flatbed truck a set of superchargers with stacks of battery packs. This is part of the modular deployment of just-in-time superchargers. And they were able to bring that to the race event and then bring it away to where it's needed next. The factory production methods, some of them are being containerized. They're being put on Tesla semi-truck sized payloads so they can be dynamically moved around the facility while they're in production at highway speeds. This is, I'll at least say unusual, if not unheard of. Now that only gives you XY. It gives you the plane of movement per floor for semi-truck operation. Up and down, that is what the robots are being used to do more, is to hand up and receive down vertically. And there's also chutes to drop down. We're seeing some of that in some of the footage from Drinheid, from GIGA Berlin. The fundamental takeaway here is Tesla, when people talk about Elon Musk playing 5D chess, yeah, that's true. The factory is laid out that way. And I'm not aware of any other facility globally that is. It's fundamentally a structural difference. Now, why is this important? The ability to maintain fast innovation is at least an order of magnitude higher than what's been able to be achieved in Fremont, California at the former NUMMI facility. And that's simply because that facility is poured concrete structure of a shape made to accommodate 2D sequential steps, single one-piece continuous flow, which is the Toyota production method, which got Toyota very far. But what it doesn't do is shorten innovation cycles. Tesla then forced into this concrete box their three-dimensional, non-linear pace of innovation. So now let's imagine again, because I don't have a drawing of it, but look at any of the pictures of GIGA Berlin, and then now even more so GIGA Texas. And you have a production step. The example I used was making seats here, and there's another one here, and they're feeding off in multiple directions because they serve S, X, 3, Y prototypes, Cybertruck. What you can do, and what they do multiple times every day, is change what seat is being made in one of those. So you have some of yesterday's seat model being made, and you have some of a new seat model being made. And then there's a change in the other one.
You mean new iterations of seats or seats for different models, like for
new iteration of seats.
New iterations.
As of today, all 4 Tesla products that are on sale use the same seat. S, X, 3, and Y, it's the same seat. Now, what that seat is changes multiple times a day. The reason it can change multiple times a day and in different spaces. So you might have production of version 23Z here and production of version 23A here. So you have a mix of different types of product in production at the same time because there's more than one production point. Then you can experiment with something new in production in these agile cells while still providing flow from the previous version, accepted version. And you can alternate. And in fact, there's often more than 10 points of production for any one given part. So you could have, in fact, you usually do, more than 10 versions simultaneously in production. And they're all backwards compatible with each other. So no matter which of those versions reaches which car, it fits, it works, it's tested, it's compliant. So 10 different seat types of the same type of seat can go almost at random to S, X, 3, and Y. This enables the legendary pace of innovation in Tesla from the factory structure. And the only way to do this is if you create your own factory. And no one is currently treating their factory as the product like Tesla is. And no one is treating it as a three-dimensional space like Tesla is. And now that they have the largest enclosed space on planet Earth in North America and in Europe, and China is growing to be almost as large right now in Shanghai. And then also Buffalo, New York is not said as often as it should be. It is also amazing. You have the physical structure optimized for pace of new product invention, pace of new product introduction, which no one could do without scrapping their current factories. The best they could do is Fremont, California, which is GIGA version 1.
And you've spoken about these 5D chess, how these hexagons are working in 3Ds. And even you've said like the semi, that is really interesting because at the beginning of the construction of the GIGA Austin, they were showing some structures with corridors in between. So they said that it would be used for semis. But I wanted to ask you, it's really clear the difference with Fremont that you were working, but what about GIGA Shanghai? As far as I know, you were not in GIGA Shanghai, but I know that you're really knowledgeable. So how different is GIGA Austin from GIGA Shanghai?
Yeah, so for current travel, it is difficult still to travel between the US and Shanghai. I do have a business visa with multiple entry to go both locations. It's still challenging, mostly because of COVID restrictions. As some of you know, GIGA Shanghai was just forced to close for a period of time just a few weeks ago.
Yeah,
now they're open right now, but traveling back and forth is heavily regulated by the governments and challenging. In GIGA Shanghai, you have some, you could think of it as Gigafactory version 1.5 or Gigafactory version 2. If Fremont, California is Giga 1, you have some of everything that you're seeing in Giga Austin, and you're seeing some of everything you're seeing in Giga Berlin. You don't have all of it. There's still sections of almost sequential process. There's at least room on each side to feed in. And that's what was prototyped in Fremont in the Model 3 tents, which are still used. So those are sprung structures, right? Where you can open either side of the tent in any location to feed in or take out part. But you have largely a sequential flow inside, largely, and then feed in, feed out dynamically from the sides. And that does change multiple times a day. That is what Shanghai is built to be able to do. And they have some level of up and down. What is novel and new above and beyond Shanghai, which is already awesome, like truly awesome. Their production numbers are trending to be over 1 million cars a year publicly, not giving insider information here publicly. Now, right? It's
incredible.
I mean, it's insane.
Yeah.
The GIGA Texas volumetric efficiency is able to be at least triple because of the level of top and bottom feeding. Now you have angular feed as well. So you have room for possible 9x, 1, 2, 3, 1, 2, 3, possible 9x increase in production efficiency in GIGA Texas and GIGA Berlin, even over Shanghai, which is already 1 million units a year. So as absurd as it is to say, the volumetric efficiency of GIGA Texas and GIGA Grünheide could reach a theoretical limit of around 10 million units a year per facility. And when Musk talks about the scaling to extreme, getting to 10 million a year, each facility has that as a possible spatial production density. So Musk continues to be very gentle. Musk is famous for not alerting the competition while being completely honest and transparent. Famous for this. Like 2 weeks before full self-driving alpha, Musk saying to the lead of Google's Waymo, when Waymo was still owned by Google, yeah, don't get into autonomous driving. It's just too complicated a problem. And Musk was honest. Everything Musk said was real. But then like 2 weeks later, it was around that timing, Musk releases full self-driving alpha. And the competition's shocked, right? Well, it's like that. It's radical innovation right in the open. So when Musk says the goal is 10 million units a year to grow towards that, already geographically, the possible production output is getting closer to 40 million a year with the footprints that are already built.
And this is mind-blowing, but I think the naysayers might say, okay, this is really incredible, but even though Tesla is vertically integrated, they still have suppliers. And lately I have seen one of your interviews. Every time that I see your interviews, I find amazing new things. So I think it was one from Israel. And it was really interesting that you explained how the die set for stamping and casting, you were while Tesla changed and pushed these suppliers to move from a few years to 45 minutes. So could you explain how you experienced that supplier pace of innovation?
Yeah, well, first, I think there's a really important word choice here. Tesla doesn't seem to push any suppliers. It seems to invite them. And I mean this very honestly. And as small a difference as one word is, push to invite, it really seems to change the way suppliers choose to work with Tesla. So Tesla offers contracts that are year-long or longer, saying, would you engage with us on this cadence? Once a supplier is able to deliver at that cadence, Tesla says, we'll still give you a year contract or longer, but we'd like inside that contract to change what the product you're making for us is on a shorter cadence. Can we change it every 6 months? You have a year-long contract, maybe longer, but every 6 months, can we have a review point where we get an update? Then, if that's achievable, can we do it every 3 months, every 1 month, and eventually, as you said, 45 minutes, some cases even faster. At that point, the supplier is typically inside Tesla, as I spoke about before. They're typically working in the same building, and the fact that they have a different company name on the paycheck doesn't even matter. It's as if they're a Tesla employee. Now, there's a fundamental inefficiency most of the time to pay another company to pay their people. So by the time a supplier is that good, that's typically when Tesla offers to buy them, if they're interested. Again, there's never a forced buyout. There's an invitation, right? Look, we can be even more efficient with you if you just become Tesla employees. And Tesla has done that many times, as we've seen in the public news as well. So Tesla engineers work very closely if the suppliers welcome them in the suppliers. So the supplier employees are treated like Musk company employees anyway. They start to be offered to work the same way with the same culture if they're interested. And the suppliers who choose to accept that invitation, they get excited about it. It's invigorating to them. They want to reduce lead times. Tesla does more and more business with them. And they profit from that. And they also help achieve the mission. Many of them are also mission driven. So the word choice between invite and push, I believe, is important. I think suppliers would burn out and decline working with Tesla if they were pushed. Whereas instead, people who are excited and motivated by the mission and are interested in continuous improvement already anyway in speed are drawn to Tesla and accept the invitation, and it grows. Tesla prefers not to make stuff in-house. They prefer to use suppliers. The problem is the efficiency, financial efficiency and time efficiency is usually much faster inside Tesla. Anytime a supplier is able to deliver faster and more efficiently than inside Tesla, Tesla prefers to use the supplier. So vertical integration is almost an unfortunate necessity.
They need to. And for this pace of innovation, you've explained extremely well in all your videos and interviews, the digital self-management. And I wanted to ask you, because I was reading the second patent of the tabless 4680, how they do the how they, instead of having one tab, they have a continuous tab of flags, and how they make it the push. And afterwards, they explain that to do the quality, the QA, they take pictures and they do a machine learning to check how they're doing. So that, when I read it, I reminded of all you've explained about quality authentication and digital self-management and everything. But at least for what I've heard from you especially, and for what I've read, I've seen a lot of machine learning in the production stack, especially in QA, in quality authentication. Like, where else is there deep learning or machine learning in the manufacturing side, not only in the products?
Anywhere someone would wait for approval, or anywhere someone would wait for a decision, that is the first place machine learning or digital self-management is introduced. So in Paint, which is the video I published not too long ago, where finally there was a picture published of one of the digital self-management screens. And I got to show that and explain what's going on in the picture.
I will link it, because if there's somebody who hasn't watched it, it's a really, really interesting video. Sorry to interrupt you.
It's also not very long. I think it's 6 minutes or less.
No, it's super short.
Which is good, right?
Yeah, no, it's great.
The first problem that's trying to be solved by introducing that DSM, because DSM, digital self-management, is not free. It is effort to make this stuff. It is a whole product all by itself each time. I mean, there's libraries of hardware and software that are reused, but each time it is a non-insignificant project. So why would you do that? Why would you use that time and money to make that hardware and software be DSM, be digital self-management for that space? Well, without any DSM, how do you do paint verification? Is the paint quality excellent? Is it absolutely amazing? You have an expert technician look at different angles on the car that's been painted and have light at different angles. And if you're doing full verification of every cubic millimeter of the enameled surface and the painted surface, that might be a day per car, truly. And this is why hand-built and coach-built products still have a prestige about them, because there is an expert craftsperson examining every square millimeter or even cubic millimeter, depending on the enameling you're using and the buildup. And it might take a day per vehicle, right? So that's a very high quality bar. It's a very slow test. You're waiting, if you're in paint and you're configuring robots, or you're mixing paint chemicals, or you're working with adhesives and coatings that are then going to interact with the paint, or the shape, you're changing the shape and you want to see how that affects the light refraction when the paint is built up on that shape. You then wait for the expert assessor. And if they're busy today, or if they're busy this month, you don't get feedback until that happens. Digital self-management is deployed here to answer that question. So you're not waiting on that expert. So instead of the expert looking at the angle of every square or even cubic millimeter of the car, shining light from different angle, using a mirror, maybe a clay bar on a surface to then see how it responds and then check light again. Instead, you have a bank of high definition cameras that essentially videos the car from many different angles simultaneously. It's the same as the autopilot stack. And it counts each photon of light returning back to the cameras. And the frequency of the photon of light tells you what color it is. Its color spectrum, as the human eye might perceive it, or even other eyes, animal eyes even, but it tells you what color it is. Then the number of photons coming back tell you the intensity. So if the camera points straight down directly perpendicular to a surface, and you know the direction of the light that is provided, you know how much intensity that color projects back. Then what you want to know for really interesting curvatures is, as the part curves away, how rapidly do you get a different color or different intensity? This is what creates depth and interest and optical movement. Well, that can be done in less than a second with machine learning stacks and many cameras looking at the car. So you've taken what was a one day on a fast, like if that expert has no queue, they're not waiting on anyone except you. So they're just waiting on you and they're ready whenever you want. You've taken it from a 24-hour delay approximately to imperceptible delay, less than a second. What that means is you can try new paint mix, new robot nozzles, new undercoatings that interact differently with the top coats, new tints in the buildup layers, new curvatures of the parts that then interact differently with those paints as fast as you want. You can try it all the time. You can try it once a second, because the digital self-management answers the question of what would an expert paint craftsperson have to say about the change you just made. You've removed that cost of delay. Well, anywhere that that's helpful, which is basically everywhere, Tesla has DSM. So if it's new seat cushions, if it's different odor repellents in the seat fabric, if it's different controls in the way you interact with the seat, if it's different windings inside the motors with different types of carbon. We're moving from different toe widths of carbon, wrapping around the different components of the motor. The DSM will give a useful answer at the level of an expert craftsperson in less than a second. And that is the superpower of Dojo and of the Tesla chip, is being able to do even more of that even faster. And this is why the innovation pace in Tesla is so bizarrely different than anywhere else. It's the DSM. You don't wait on a manager. Now, this is also true for spending money, which is fundamentally important. That you might ask, is it okay to spend money on these robots or on these logistics or on expediting to air freight or whatever? The DSM gives you as good an answer as an expert manager would have. So now you just execute. You've removed your wait state. You've removed your delay. So that's being used in, yes, seats. It's being used in logistics. It's being used in when do we use air freight versus surface freight. It's being used in the layout of where should trucks dock. Should we use cross docking here? What should we use? It's being used in three-dimensional volumetric efficiency. Anywhere you'd wait on an expert opinion, DSM is there. And the capability of DSM is improving as fast as the machine learning gets data. This is why, as Tesla volume increases, they don't slow down their innovation. This is incredibly unusual. In almost every company on planet Earth, as the company's size increases, the lead times also increase. The cost to make the same thing goes down, but the cost to change goes up in almost every company. This is not true in Tesla. And it's because of the active, aggressive development and deployment of digital self-management. And because digital self-management relies on machine learning stacks, which improve with larger data sets, the higher Tesla's volume, the faster Tesla becomes at innovation and efficiency, because the data set feeding the DSMs, all of the different DSMs, grows, improving the quality of DSM.
We have to innovate fast also in this interview, Joe, because I see that, I don't know why, the Zoom has said that I have to upgrade my account. All this that you were saying is amazing, especially after my messing up with Zoom. And I wanted to ask you, because this is one comment that few people did after our last interview, that I was asking you how far ahead was Tesla in comparison to OEMs. And people said, okay, but the competition of Tesla are not OEMs, are the Chinese companies and the American startups. So all this space of innovation that you're speaking about, all this digital self-management, how are the startups that they have been born natively digital in comparison to Tesla? Lucid, Rivian, Neo, Spence, et cetera, et cetera.
Now, strangely, none of those companies so far have applied agility to their hardware. So the idea that the hardware can change many times very frequently isn't happening yet. And we're seeing that in Rivian in their announcements of their fixed supply chain commitments, as they attempt to negotiate fixed commitments for the same part number over a larger volume. You're seeing a lack of interest to change the hardware. And strangely, this is from startups who are familiar with the rate of change in software as a good thing. And they're not yet understanding agility in hardware, what gated check-in in hardware should mean, what DevOps in hardware should mean. And they're using waterfall or big planning up front for hardware. We're seeing this across BrightTop, Super Cruise, which is a sort of a startup inside General Motors or acquired by General Motors, Rivian, Lucid, Lordstown Motors had none of this and maybe went bankrupt and maybe didn't and continues to have issue. Nikolai as well. None of them have a focus on iterating the speed of change and increasing the speed of change in hardware. This is still strangely Tesla's moat, is their ability to engineer and deploy in production rapidly. Now, these companies should know better. They've understood the benefit of speed of change in software, but so far, none of them have deployed that to hardware. Now, to Tesla's credit, Tesla had difficulty with this in the beginning as well. When I was first consulting with Tesla in 2010, the Model S had limited modularity, which made few parts that could be designed, engineered, and deployed in parallel. There were some, but few. And the focus of the work that I originally got to collaborate with the Model S team was on increasing the parallelization, the number of parallel channels in hardware that could be changed, designed and changed at the same time. The 3 and Y have an incredibly high amount of parallelization. The level of modularity and known stable interfaces in hardware, which is the same as you would use in software, is extremely high. None of the other hardware companies have this yet, but to their credit, Tesla had limited amounts of this early on as well. But that means we're likely several new products away from possibly having the parallel pace of innovation as Tesla, especially this first batch of new products from each of these startups is maybe as modular as the original Tesla Roadster. Which is to their credit. They are new thinking, cool companies, but that means it's more than 10 years out of date already on their current crop.
Going back to our conversation about the GIGA Austin, you've said that it might be prepared for semis moving, and thinking ahead about the new workers that this factory will have, the Tesla Optimus, you said that is the dream of all the Agilists because it has all the auto labeling from a human factor point of view. How did you see this factory being adapted to the needs of the Optimus, or do you think that the design was in somehow prepared to these new kind of robots workers?
Now, you have a charging infrastructure constant across Tesla's facilities. Tesla's buildings are electrified at a level that is not yet common. So your ability to have consistent high power, electric power, three-dimensionally in the building is structurally different in Tesla's facilities. But the power of Optimus is that it's designed to be able to work well where humans work. And so existing optimizations for human factors also play to Optimus's strengths. Now, this is an advantage for an industrial facility as well, because many industrial facilities are a compromise between a footprint and a layout that's a good fit for heavy machinery and a footprint and a layout that is ergonomic and safe for humans, much less not tiring and reduction of risk for repetitive motion. What Optimus brings to the table is even more human focus in the factory layout, even more optimization for the human profile, an approximate Da Vinci drawing of a human radius spread of arms, shoulders, legs, because the heavy equipment is mobile, able to be put on the bed of Tesla semis. So you have, instead of your stamping facility that's optimized for heavy footings for heavy stamping machines and presses, which is how most factories lay it out, you have a different floor. Like structurally, the way it interacts with the earth is different where the heaviest equipment is placed. In Tesla, the known stable interface is, can a Tesla semi drive here? If so, most of the heavy equipment can be deployed here or not dynamically. Then the next optimization is humans, human pathway. Now, Tesla did prototype this very well in Fremont, California with Human Zone. And Human Zone has colors of tape on the ground. This is not novel, but Tesla did it very well in Fremont, California. Here is an area that is optimized for human interaction, for human work, for human traffic. Here's areas that are optimized for things like fork trucks and autonomous carts and human pulled carts, etc. What GIGA Austin is much more like is like a park where you have a road next to the park that surface vehicles could go. And that's, in this case, things like the Tesla Semi, and then a park where humans can perform in a comfortable way. And that is, again, unlike any production facility I've seen anywhere in the world. To compare it to Germany, there are beautiful factories for Audi. Very quiet, very clean, very white, very expensive to change. You have the heavy equipment has been planted in the floor with custom flooring, a custom building structure around it, custom power to that unit. And then almost like a park setting has been built over it. That is lovely from a human experience point of view. It truly is gorgeous. It's also even more expensive to change, because if that is no longer the optimum place for that piece of heavy machinery, or if the operation made by that piece of heavy machinery is no longer good, you essentially have to dig it out of the factory and make a new custom setting for it. And so now that's a year-long operation, which no one wants to do. So you end up using the wrong machine unoptimally for years. sometimes decades, because that's where it is. And it's difficult and frustrating to move it. And it's high budget, and I have to advocate for budgets. Now I have to make presentations to justify the budget to move this machine. And that brings into question, why did I request that machine go there in the first place? And now I look bad, then I'm unlikely to get promoted. Typical fiefdom, old style king and castle style management, 1,000-year-old thinking, management problems, none of which I experienced as an employee in Tesla. It was simply, what does the data say about optimum capital efficiency and efficiency of innovation? So the Tesla bot, really its power is that it's more like a human, and you get to optimize the factory better for humans and then rely on Tesla bot.
Really interesting. And right now, as we're ending our time, I wanted to show you, Joe, one video, and I want you to tell me what you think about what this, maybe he's even a robot, who knows, is saying. So hold on, share screen. Yeah, share screen.
At this point, I think I know more about manufacturing than anyone currently alive on Earth.
Tweet that.
Yeah.
Thank you. The only problem is I didn't hear it, Alejandro.
Okay, so I will tell you, because right now this is being a great video with stop share. Is Elon Musk sharing that he's the person who knows more about manufacturing than anybody on Earth in the TED conference? So what do you think about this statement?
That is unequivocally true. And the last person with a similar level of knowledge in a similar field was Gordon Murray, who created a car with a very large team, a car that Elon Musk actually bought. And Elon said it was an amazing car. That was the McLaren F1. That was a Gordon Murray design. Gordon Murray is largely credited as being the last person since Elon Musk to understand how to engineer and build every part of a car, all approximately 10,000 parts. And it's completely true from everything I understand about Gordon Murray. I've not worked directly with Gordon Murray, but everything I understand is that's true. Now, Gordon Murray is still at this game, working with many teams, very large teams globally, and making very interesting products. What is different about Musk is not only can Musk also do this now. What is different about Musk tells me it's almost the next appointment. What's different about Musk is Musk joins the production. Musk actually, Gordon Murray does the design with teams, is in 3D design tools, is talking to suppliers, is validating supplier concepts. And as a result, the level of innovation is much higher because Gordon doesn't have to just accept at face value any statement from anywhere else. Gordon can go into the details. Well, Elon can do that as well. But Elon can also do that in rockets, in human implantable electronics, in tunnel mass transit, and in artificial intelligence. That is completely new. There is not currently anyone alive with that level of cross skill. And Elon leading these companies and making at the top level all of the essentially financial allocation decisions. I mean, people spend their own money, but Elon allows them to spend their money, right? There's no other set of companies on planet Earth with any structure like that, where you have the top person joining the engineering for 12 hours a day, 7 days a week, across all of those complementary disciplines. So you have products that emerge across those disciplines, like robotics. If you have deep skill in AI, deep skill in electronics motor manufacture, deep skill in light industrial is what we would call something human robot sized. and sense and perception and auto labeling, the Venn diagram of that covers some very interesting products. And that is what allows us to forecast what future Musk company products will be, because of the overlap of these disciplines being simultaneously understood at a very deep and practical engineering level by the person ultimately accountable for the engineering outcome and the budget, Elon Musk.
Great. As we are nearly done, because you have to go, sorry for all the technical problems, but I want to finish with our traditional game. You are already a super veteran. So, Mr. Joe Justice, I want you to answer with just one question, a few concepts that I'm going to tell you, okay? How was the party at Cyber Rodeo?
Best.
How would you define GIGA Austin?
Future.
You were in Starbase right after being in the Cyber Rodeo. I saw in Twitter. So how is the current development of Starship in one word?
Monthly.
Elon Musk Twitter acquisition.
Smart.
And the dedicated new robotaxi that is going to be unveiled next year.
It will kill all competition. Is that one word?
No, but it's great. Okay, where people they can find you in your Twitter and email that we have it, yes, here, or yeah, here is mirroring my image. Apart from that, they can buy your book, Scrum Master, that I really recommend. Where else can they contact you?
abi-agile.com, Agile Business Institute, abi-agile.com. I actually just started teaching now a new version of the Agile Hardware Developer course, which is how engineering, management, product development, and suppliers work with Tesla and SpaceX.
And I've told you privately, but I say it now publicly, that please, Mr. Joe Justice, you have to write a book about the Musk way, how Elon Musk runs his companies, because I read the Toyota way and it would be mind-blowing for the future generations. And there's no one who understands better the Musk companies, how they work than you. So please, I beg you. And could you end up with our famous sentence? Hola, soy Joe Justice y estoy aquí para que triunfes.
Hola, soy Joe Justice.
Y estoy aquí para que triunfes.
Y estoy aquí
para que triunfes.
Para
que triunfes.
Que
que triunfes. We should need some machine learning there. You live in the best moment in history. Enjoy! If you like this video, please give it a like, leave a comment, share it with the whole universe. And since I want to make interesting videos for you, I need to know what interests you. Write your suggestions. If you have enjoyed this type of content, subscribe to this channel so you won't miss any future videos. I'm working hard to make the best possible content for you, but it takes time. Consider supporting me in Patreon, the best moment in history, so I can stop living under a bridge and continue creating content for you. There's a link in the description. Thank you very much from the heart. Gracias.